Sir, I have another question if I could just ask before we start.
Yes, you
Uh,
can ask the question.
जी, sir, तो it's about the determinant. You said कि अगर determinant greater than 0 होगा of a matrix तो of two vectors तो फिर उसका एक unique solution होगा. मगर for the other case, if determinant is 0 or less than 0 तो फिर उसके infinite या no solution होगा.
No,
Is
I didn't say that. Determinant should be non-zero. This is the condition for a unique solution.
okay,
Okay.
non-zero, right?
If the determinant is zero, then there might exist infinite many solutions or not no solution. Okay. This is the correct condition. Previously, in the previous lecture, we discussed a system of 2 by 2 linear equations. Today, we are going to discuss system of 3 by 3 linear equations, and then we shall generalize this concept onto a linear system with 4 unknowns, 4 equations, and even 10 equations and 10 unknowns, or maybe 10 unknowns and 8 equations. We'll discuss bigger linear systems, but first we need to discuss 2 by 2 and 3 by 3 linear systems. So people are still trying to join in. I would request you all to join before 4 o'clock so that we don't waste our time by waiting other people. So a 3 by 3 linear system, today we are going to discuss this 3 by 3 linear system. 3 by 3 linear system means a linear system which has 3 unknowns and 3 equations. After discussing this, we'll discuss a couple of applications. Where do these systems come from? What are the practical applications of these kind of systems? We will discuss this in the next lecture. Now, let us have a linear system of this kind, maybe 2x plus 4y minus z is equal to 7, x minus 11y plus 4z is equal to 3, and then 10x1 minus 6x2 plus 4z is equal to 3 again. So this is a linear system in 3 equations and 3 unknown. Can anyone tell me what a single equation represents in 3D? Because we have 3 variables. So what would this equation represent in 3 dimensions? If we suppose this is x, this is y, this is z. Anyone? A straight line, you know, it represents, sorry, a linear equation in 2 unknowns, it represents a straight line. Now, what a linear equation in 3 unknowns represents in 3D? It represents a plane. Okay, I hope you know it. It represents a plane. Now, whenever we have 2 equations in 2 unknowns, for example, 2x minus 3y is equal to 1 and x minus 5y is equal to 3. For example, this one. What we are talking about when we discuss 2 by 2 system, we are discussing 2 straight lines. Okay, this one and this one. For example, if these 2 straight lines, if they have unique solution, they are intersecting at a single point. Okay. If the in 2D, x and y, if they are not intersecting, if they are parallel, then there are 2 lines which are parallel, they're not intersecting. So this system doesn't have any solution. And if one line is on the top of the second line, then there are infinite many solutions. This is what we had discussed in the previous lecture. Now, if we discuss 3 by 3 system, a single equation in 3 unknowns represents a plane in 3D. Okay. Now, if we have 3 equations, then all these 3 equations are basically representing planes in 3D. Now, what we are talking about linear system in three unknowns in three equations. We are discussing that there are three planes and they are intersecting with each other by some manner. How many possibilities are there if we have a three plane? They intersect at a single point. They intersect at a single point. Let me show you a picture which I gave in my first lecture. Let me share this thing with you. There's a question in the chat window. Resultant. Who said this? Muhammad Abdullah. What do you mean by resultant?
No, sir, I was just guessing. Sorry.
Okay. Let me share you this screen. Share screen. And this picture. I hope everyone can see this picture now. Now, you can see that in this picture, there are three planes, okay? In first row, the first case is there are three planes and all the three planes are parallel. Then there will be no solution because there is no intersection in these planes. In the first row, second case, this one, three planes are intersecting at a single point, which is here in the middle. So in this case, the 3 by 3 system will have a unique solution. In the line 1, case 3, this one, the planes are intersecting, but all the three planes are not intersecting at some common region. There is no common region of intersection in the case 3 of first line. So in this case also, these three equations or a 3 by 3 system would not have any solution. In the line 2, case 1, one plane is intersecting the two other parallel planes. So there is no common region of intersection here. The 3 by 3 system in this case would not have any solution. Line 2, case 2, three planes are intersecting at a single point, this one, which is in the middle here. So in this case, the 3 by 3 system will have a unique solution. In the second line, third case, all the three planes are parallel. Parallel and they are on the top of each other. Means there is only one plane. In this case, there will be infinite many solutions because all the three planes are intersecting at infinite many points. In the row 3, case 1, two planes are on the top of each other, they are coincident, and the third plane is intersecting them. Now there is a common region of intersection in this case. The common region of intersection is a straight line. I hope you get it. The common region in this case, line 3, case 1, the common region is a straight line. And a straight line have infinite many solutions, have infinite many points common, okay, in these three planes. So there are infinite many solutions. In the line 3, case 2, this one is all the three planes are intersecting and the region of their intersection is a straight line again. So there will be infinite many solutions because the point of intersections are infinite. In line 3, last case is also infinite many solutions because all the three planes are intersecting and their common region of intersection is a straight line. So there are infinite many points which are common in these three planes. So there will be infinite many solutions. I hope you get it. If you have any question, you can ask me.
Sir, can you explain line 3, case 1 again?
Case 1. Line 3, case 1 is two planes are on the top of each other, and the third plane is intersecting them. So what is the region of intersection in this case? The common region of intersection. It's a straight line. You got it,
Yes.
Fatima?
Yes, sir.
Sir,
So
what is the difference between the Last and the second last.
There's no difference. They are just, their orientation is different. But their common region of intersection is a straight line. So there are infinite many points common in the intersection. So there are infinite many solutions. You got it?
Yes,
Sir,
sir. Thank you.
Ji beta. Next, anyone
Sir,
question? Ji ji.
line 2, third example, उसमें भी infinitely many solutions हैं.
Yes,
They're
because all the three
infinite.
planes are on the top of each other. So
Right.
there are infinite many points of intersection in these planes.
Right.
Okay.
Okay.
When there is no common region of intersection between all the three planes, for example, line 1 case 3 and line 2 case 1. Line 1 case 3 mein dekhein, planes are intersecting with each other, but all the three planes, they do not have common region of intersection. So there will be no solution. In the case 1 of line 2, also all the three planes are intersecting, but their common region of intersection is, there is no common region of intersection, okay? So when all the three planes are intersecting at a single point, there will be a unique solution, there will be one solution. When all the three planes are intersecting and there is a line of intersection, straight line of intersection between the three planes, then there will be infinite many solutions, okay? And when all the three planes are on the top of each other, then there is again infinite many solutions. I hope you get it. I'm gonna stop sharing this picture and we are going back to the board for further discussion on these things. I hope you get it. If you have any further questions regarding the number of solutions in the 3x3 case, you can ask me. So we don't need this figure now. I hope you got it. Now, mathematically, what happens if all the three planes are on the top of each other? We have three lines, for example, x plus 2y plus 3z is equal to 1. And the other is 2x plus 4y plus 6z is equal to 2. And 3x plus 6y plus 9z is equal to 3. So if we have this kind of linear system 3x3, you can see that the line 2 is a multiple of line 1. Oh, sorry, plane 1, equation 1. Equation 1, if we multiply equation 1 by 2, we get second equation. If we multiply equation 1 by 3, we get third equation. So technically, all the three equations are identical. So in this case, the three planes are on the top of each other. We have only one plane, in fact. So in this case, we'll have infinite many solutions. Okay. So in fact, we have only one equation, x plus 2y plus 3z is equal to 1. So we need to solve only this equation. How do we solve it? I told you in the previous lecture that if we have one equation and three unknowns, or let me restate it in another way. If we have three unknowns, we must have three equations to find all the three variables. Okay. If we have three unknowns and one equation, then we have to set two variables free as a free variable. So any one of these two, you can set as a free variable. So I'm supposing that y is some free variable t and z is some free variable r, where t and r, they belongs to r. So now if we set two of these three variables as a free variable, then the third can be calculated. X will be what? The value of x will be 1 minus 2t minus 3r. Okay, where t and r belongs to r. In this case, the solution would be what? In this case, the solution would be x, y, z, and we can write it x as 1 minus 2t minus 3r, and y is what? y is t, and z is what? Z is r. So this will be the solution. And by taking different values of t and r, we can have infinite many solutions. Because t and r, they can have different values from r. So they have, in fact, infinite many values, and this system has infinite many solutions. And further, this can be written as I told you in the previously 1, 0, 0, because this can be written as 0 plus t plus 0 and 0 plus r plus 0. So we can separate them 1, 0, 0 plus t common ले लें आप, t common लें तो क्या आएगा? -2, 1, 0, and the third one r common ले लें, r common लेंगे तो क्या आएगा अंदर? यहाँ पे it would be -300. So -300. So this will be your solution to this system. And this is infinite many solutions. I hope you get it. If you have any question, you can ask me. This is basically a parametric form of equation of a plane. Yes.
ये जो मिडिल वाला है इसको एक्सप्लेन करें जिसमें आपने t को कॉमन लिया है.
देखिए जब आप t कॉमन लेंगे तो सिर्फ t का कोफिशिएंट आना चाहिए ना यहाँ पे. So there is no, यहाँ पे 0 आ जाएगा, यहाँ पे r लिख लें आप, यहाँ पे 0 और यहाँ पे r. So in fact 1, 0, 0, because it's a constant term is separated. Now the terms which contains t, they also have been separated. And then in the third case, we have separated the terms with r and took r as a common. So it becomes -30 and 1, not 0. We must write here 1. You got it now?
Yes, sir. Thank you.
Okay, thank you. Now you can have a look at this. If you have any question, you can ask me.
सर आप स्टेप वाइज या फिर एक बेसिक रूल बता सकते हैं पैरेलल उनको सॉल्व करने का, पैरेलल प्लेन्स को?
If there are parallel planes, then there will be no solution.
Right.
Okay,
So-
we'll discuss these things further when we discuss Echelon forms of the matrices and their matrix representation of these linear systems. You would definitely understand these things in more detail when we go further with this course. Okay.
Okay, sir.
Okay. Let me now go back to this example. You would definitely know all these situations when we go further discussing these things. When in which case the planes will be basically this 3x3 system, in which case it will have infinite many solution, in which case the system will have no solution, and in which case the solution have unique solution. Okay. Now, if we call it line 1 and line 2 and it's not line, equation 1, because these are planes. So you can say that this is equation 1, this is equation 2, and this is equation 3. Now, when in your earlier classes in intermediate or in A level, how do you solve equations simultaneously? You multiply this equation, for example, this equation by 2 and then subtract from this equation. You can eliminate x. This is how you do. Okay? And in solving or while solving linear equations, you can apply certain operations on these equations in order to solve them simultaneously. For example, you can multiply an equation on both sides by a constant. You can subtract one equation from other. You can interchange two equations, any two equations. You can put equation 1 at the place of equation 3 and 2 at a place, some other place. So these are some of the basic operations you can use in order to solve simultaneous equations. I hope you understand it. I hope you know it. Are you agree with me? If you have any confusion, you can ask me. The next is equivalent systems. या बल्कि आप कह सकते हैं कि how to write this matrix, sorry, this system into matrix form. I told you this would be 2, 4, minus 1. ठीक है. X, sorry, not X. 1 minus 11, 4, and 10 minus 6, 4 times X, Y, Z is equal to 7, 3, 3. So if we call this matrix as A, this is a vector, and this is the right hand side of this. So this is how I told you we can write it in a matrix form.
Sir, I
Now,
have a question.
जी बेटा,
सर ये जो सिस्टम लिखा हुआ है इसके अंदर कितने वेरिएबल्स हैं?
इसमें आप बताएं मुझे कितने वेरिएबल्स हैं?
सर मुझे इसमें 4 नजर आ रहे हैं.
आप बोले.
3.
हाँ, 3 variables. There was a mistake here. So 10x minus 6y plus 4z. Sorry.
It's okay.
So all the variables should be same. ये नहीं हो सकता कि x, y, z आपने लिखा हुआ है और नीचे जो है ना कुछ और हो. The variables should be same in all the systems. Now, this is the corresponding matrix form of this linear system. Now, there is another matrix representation of this linear system. We call it augmented matrix. Augmented matrix. Augmented matrix, how we write it for of any linear system, we write in a similar manner the coefficients 2, 4, minus 1, 1, minus 11, 4, and then 10, minus 6, and 4. Now you draw a line here and write the right-hand side vector, 7, 3, 3. So this is called augmented matrix. And how do we represent it? A subscript B. Okay, this is called augmented matrix for that corresponding linear system. Now, if you want to solve this system simultaneously, what operations you can apply on that linear system? Basic operations. In order to solve that linear system, what you do, if we call this is equation 1, E1 आप इसको कह दें, so that easy हो जाए थोड़ा सा. E1, E2, and E3. Equation 1, equation 2, and equation 3. Now, how to solve this system? What operations are allowed in order to solve any linear system by using simultaneous method? We can interchange for first operation. Interchange any two equations. It is allowed. There will be no difference in that linear system and the resulting system, linear system, after interchanging the equations. There will be no effect. Second, we can multiply any equation by a constant on both sides. Would there be a change in the linear system after doing this operation? No. So these two operations, they do not change the original linear system. The original linear system will remain same after doing these two things. Number 3, subtract a multiple of an equation from some other equation. This is also allowed. What does it mean? We can multiply this any equation by some constant, and then we can subtract it from some other equation. This is also allowed. It doesn't change anything in the linear system. So these are three basic operations which we can apply on a linear system in order to solve them simultaneously. And how do we? Yes, Zibida. Any question? No. Okay. How do we represent these these operations mathematically? The first, in which I told you the interchange any two equations. How do we represent it? We represent E1 interchange with E3, for example. This is how we represent the first operation, interchange any two lines, any two equations. For example, if you want to interchange equation 1 and 3, how do we represent it? Equation 1 and this sign, equation 3. It means that we are going to interchange in the previous linear system, equation 1 and equation 3. Number 2, how do we represent that? We can multiply an equation by some constant. For example, we say that we are going to multiply equation 2 by a constant. This is how we represent it. Okay. And number 3, we can subtract or add a constant multiple of some equation. We are going to multiply alpha times equation 1 into another equation, for example, equation 3. Okay. So this is how we represent the third operation. This is how we write them mathematically. Okay. Now, all these three operations on equations, when we apply on a linear system, when we apply all these three operations on this linear system, this is equivalent to apply all the three operations on this matrix. Because if we apply these three operations in this linear system, what would change? Their coefficients will change. X, Y, Z would remain same. So now we are going to systemize this, systemize a method. We are going to basically discuss a method in which we are going to convert the given linear system into a matrix form, which is augmented matrix, and all these three operations will be applied on this augmented matrix. In fact, all the three operations which we apply on this linear system will be applied on this augmented matrix. There will be no change in these two methods. Now, we are going to define elementary row operations. Elementary row operations. Now, there are rows in that matrix, this augmented matrix. In this augmented matrix, now we have rows. This is row 1, this is row 2, this is row 3. Instead of equations, equation 1, equation 2, equation 3, now we say that these are rows in a matrix. Okay, so this is your row 1, this is your row 2, and this is your row 3. Okay, now the similar kind of operations which we have applied on a linear system, the same kind of operations are basically defined on rows now. R1 can be interchanged with any row in that augmented matrix. Second operation is what? We can multiply any row by some constant. Third one, we can add a multiple of some row into some other row. Okay. We can multiply row 1 with alpha, and then we can add them in row 3. In this case, which row will be changed? Row 3 will be changed. Okay. Row 1 will not be changed because we are multiplying row 1 with alpha, and we are going to add that row in row 3. Row 1 will remain same, but row 3 will be changed. Okay, this is how. These are basically exactly same operations which we apply on a linear system. Now we call them row operations, okay, or elementary row operations. Next thing, yes, beta, जी बोले.
सर अगर हम सब्ट्रैक्ट करें तो ऑपोजिट होगा ना?
हाँ, बेशक सब्ट्रैक्ट कर दे. You can multiply R1 with alpha and subtract from row 3.
तो सर फिर रो कौन सी चेंज होगी?
फिर भी रो 3 ही चेंज होगी इन एनी केस. आप इसको इस तरह अप्लाई ना करें, इसको हमेशा आप जो है ना प्लस रहने दें. अगर आपने R1 को कुछ किसी कांस्टेंट से मल्टीप्लाई करके R3 से सब्ट्रैक्ट करना है, तो आप इसको नेगेटिव अल्फा से मल्टीप्लाई कर दें. ठीक है. You multiply R1 with negative alpha and then add in row 3. The row 3 will be changed. Okay. Now, we can apply these 3 operations on that augmented in order to solve the given linear system simultaneously. Basically, we are making a systematic method in order to solve that linear system simultaneously. ठीक है, जैसे आप दो इक्वेशंस को सॉल्व करते हैं तो कैसे करते हैं सिमिल्टेनियसली? किसी एक वेरिएबल के कोफिशिएंट को सेम कर लेते हैं, वो कैंसिल हो जाता है, फिर आपके पास दूसरी वेरिएबल की वैल्यू आ जाती है. ऐसे ही करते हैं ना. तो यहाँ पे भी हम वही मेथड अप्लाई कर रहे हैं, बट वी आर ट्राइंग टू मेक अ प्रॉपर प्रोसीजर ऑफ दैट थिंग, नथिंग एल्स. अब हम क्या करते हैं, ये जो ऑगमेंटेड मैट्रिक्स है उस पर ये ऑपरेशंस लगाते हैं. ठीक है. We are going to operate these operations on that augmented matrix. Now, what was the matrix now? The augmented matrix corresponding to given linear system is what? It is 2, 4, -1, 7, 1, -11, 4, 3, 10, -6, 4, 3. Okay? This is your augmented matrix. In some books, यहाँ पे line लगाते हैं, in some books, आप line ना भी लगाएं, it doesn't matter. But you know that this rightmost column is the right hand side of that linear system. Okay. अच्छा, अब हमने क्या करना है? We are going to use those operations in order to solve this linear system. Step 1. How to solve? Try to make the first entry, try to make it 1. The first entry of the matrix, try to make it 1 by using any of these 3 operations which we have discussed earlier. Now, can anybody tell me what operation we can apply here to make 1 here?
Divide by 2.
Yes, this is 1. This is the first option, that we can divide the whole row with 2. Then we can make here 1. Any other option which is more appropriate? There's a chat
Interchange row
window.
2 with row 1.
There's a question in the chat window. R1 and R2 interchange row 2. Yes, that would be more easier if we interchange row 1 and row 2. Okay. Step 1 is what? Make first entry one. Okay. Make first entry in first row equal to 1 by using any appropriate operation. Either you can divide the whole row by 2. What, in fact, what you are doing here, you are multiplying the given equation by 1 by 2. ठीक है, आपके पास पहली ऑप्शन क्या है, आप 1 by 2 रो 1 कर दें. ठीक है, ये पहला ऑपरेशन है, यहां पे 1 बन जाएगा, पूरी रो को आपने 1 by 2 से मल्टीप्लाई करना है. सेकेंड ऑप्शन इज you can interchange row 1 and row 2. Okay. Third option is what? R2 minus R1. Okay. लेकिन इसको लिखेंगे ऐसे नहीं, लिखेंगे उस तरह जैसे मैंने बताया. इसको कैसे लिखेंगे? -1R1 plus R2. In this case, which row is going to change? R2. Okay. इसको आपने ऐसे लिखना है, ऐसे नहीं लिखना. ठीक है, so these are the three options which we can use here in order to basically make one here. ठीक है, so you can apply any one of these. I'm going to apply this one, second one. So यहां पे आप क्या कर रहे हैं, R1 interchange with R2. ठीक है, this gives us what? 1 minus 11 4 3 2 4 minus 1 7 and then 10 minus 6 4 3. This is what we have obtained here. I'm going to erase it. I hope you got this point. Now what we do in the next step, step 2. फर्स्ट एंट्री 1 बन गई. अब स्टेप 2 में क्या है, इस 1 के जो नीचे वाली एंट्रीज हैं, इस 1 के जो नीचे वाली एंट्रीज हैं, इनको आपने मेक देम 0. इनको कैसे 0 बनाएंगे? यूजिंग दोज 3 ऑपरेशंस. कोई से भी उन 3 ऑपरेशंस में से कोई से आप ऑपरेशन लगाएं और इन दोनों एंट्रीज को आपने 0 बनाना है. ठीक है, इन दोनों एंट्रीज को 0 बनाना है. कैसे बनाएंगे? पहले हम इस पहले वाले को 2 को 0 बनाएंगे. ठीक है, कौन सा ऑपरेशन लगाएंगे यहां पे? एनीवन? व्हाट इज एन अप्रोप्रिएट ऑपरेशन इन ऑर्डर टू मेक द 2 0? Anyone? Minus 2R1 plus R2. That's okay. Yes, we are going to apply. First case में इसको 0 बनाना है हमने. So minus 2R1 plus R2. In this case, row 2 is going to change. Okay, not row 1. आप row 1 को वैसे ही लिख दें. row 1 क्या है? 1 minus 11 4 3. Now और रो 3 को भी वैसे ही लिख दें, सिर्फ रो 2 चेंज होगी. 10 minus 6 4 3. ठीक है, अब क्या करें, आपने इसको 2 से मल्टीप्लाई करना है. यहां पे क्या आ जाएगा? 2 minus 22. 2 से मल्टीप्लाई करेंगे 8 एंड देन यहां पे 6 आ जाएगा. ठीक है, अब इन दोनों को आपने इसमें से इसको सब्ट्रैक्ट करना है. -2 से यहां पे -2 आएगा, यहां पे +22 minus 8 minus 6. अब इन दोनों को ऐड करना है. यू गेट 0 हेयर. इन दोनों को ऐड करें, यू गेट 26. यू गेट 26 हेयर. इन दोनों को ऐड करें, -9. इन दोनों को ऐड करें, यू गेट 1 हेयर. ठीक है, पहले स्टेप में यहां पे 0 बन गया. नेक्स्ट स्टेप में हमने क्या करना है, यहां पे 0 बनाना है. ठीक है, तो यहां पे 0 बनाने के लिए क्या अप्रोप्रिएट ऑपरेशन होगा? एनीवन?
Sir,
So-
जो आपने step किया, could you repeat that? मतलब समझा देंगे फिर से? I didn't get it quite.
What one? Which one?
Sir, how did you make the second row 0? Could you recap that?
Not this entry in the second row. First entry in the second row must be 0. Okay. What do we need here in order to make this 0? यहाँ पे 1 है ना, आप इसको इस पूरी रो को -2 से मल्टीप्लाई करें और फिर इसको ऐड कर दें रो 2 में, यू विल गेट 0 हियर.
Right. So,
ठीक है, यू गॉट इट.
yep.
लेकिन जब आपने -2 से इसको मल्टीप्लाई कर रहे हैं तो इट्स मैंडेटरी कि आप पूरी रो को मल्टीप्लाई करें, सिर्फ इस एंट्री को मल्टीप्लाई नहीं करना. ठीक है, यू हैव टू मल्टीप्लाई दिस होल रो विद -2 एंड देन यू ऐड दैट थिंग इनटू दिस होल रो. ये वाली एंट्री पहली वाली एंट्री पहली में ऐड होगी, दूसरी दूसरी में, तीसरी तीसरी में, चौथी चौथी में. ठीक है.
Sir, we subtract 2 throughout the row 2 to make it 0.
हाँ.
Can we subtract 2 throughout the
No,
row
no. One of those 3 operations can be applied.
2? All right, sir.
ठीक है, क्यों? I'll tell you. देखिए, पहले अब आप जब लीनियर सिस्टम था आपके पास, यहाँ पे इस पे आप कैन यू डू इट कि आप इसमें से 2 को सब्ट्रैक्ट कर दें और इसको 0 बना दें?
No, sir.
Is that allowed in that linear system?
No.
No. Only these 3 operations which I have written here, basic operations on the linear system in order to solve it simultaneously. Only these 3 operations are allowed. ठीक है, तो यही operations हमने use करने हैं. We cannot use any other operation. Okay. So it is equivalent that आप ये operations apply करें linear system पे या आप row operations apply करें इस augmented matrix पे. These are 2 equivalent things. I hope you get it. Now we are going to make 0 here. What operation is needed? Minus 10 R1 plus R3. So what is going to change? R3 is going to change. Okay. We are multiplying row 1 with 10 minus 10 and then we add it into row 3. Okay. तो अब आपके पास यहाँ पे क्या आएगा? रो 1 चेंज नहीं होगी. 1 -11 4 3. रो 2 भी चेंज नहीं होगी. ठीक है, सिर्फ कौन सी रो चेंज होगी? रो 3. नाउ रो 3 इज गोइंग टू चेंज हियर. आप इसको 10 -10 से मल्टीप्लाई करेंगे. व्हाट डू यू गेट हियर? -10. यहाँ पे 110. यहाँ पे -10 से मल्टीप्लाई करेंगे -40 और -30. यहाँ पे आ जाएगा. अब आपने इसको ऐड करना है उसमें. तो 10 and 10 0. 110 और 6 क्या आ जाएगा? 104. and then -40 और 4 -36. and then 30 and 3 is 27, -27. This one. अब आपके पास ये 2 एंट्री 0 हो गई. ठीक है. The second step. फर्स्ट स्टेप में क्या था? आपने पहली एंट्री को 1 बनाना है. सेकेंड स्टेप में क्या है कि आपने इन 2 एंट्रीज को 0 बनाना है. ठीक है. नाउ व्हाट इज द थर्ड स्टेप? इन थर्ड स्टेप अब आप पहले कॉलम से निकल आए, दूसरे कॉलम में आ जाए. दूसरे कॉलम में ये वाली जो एंट्री है, दिस वन, यू मेक इट 1. यू ट्राई टू मेक दिस एंट्री, make it 1. Whatever operation you need, you can use from those 3 operations. यहां पे क्या ऑपरेशन है हम अप्लाई करें जो इसको 1 बना दें? Anyone? The most simple is what? You divide second row by 26, you will get 1 here. ठीक है. The operation which I'm going to use is now, let me change the board. This one here. Now the matrix, I'm gonna write it again. The matrix is 1 -11 4 3. And then 0 26 -9 1 0 104 -36 -27. This one. Okay. Now we are going to make this one 1. Make this one. Make it 1. Okay. कैसे बनाएंगे? I'm going to multiply row 2 by 126, sorry, 26. अब ये ऑपरेशन लगा दें यहाँ पे, the matrix would become, the only row 2 will be changed, row 3 and row 1 will remain same. Okay. Now 1 by 26 are 2, so we get 0 here, we get 1 here, minus 9 by 26 and 1 by 26. We get this. Okay. Now, this was the step 3. Now, what is the step 4? Below this 1, यहाँ पे आपके पास 1 आ गया. You get 1 here now. Below this 1, try to make 0. Try to make all the entries 0. Make it 0. Okay. How to make this entry 0? You can use this one, the second row. What operation is appropriate here? Minus 104 R2 plus R3. Which row is going to change? The second one, this one, R3. Now, this operation we are going to apply on the matrix now. Row 1 will remain same, 0. Row 2 will remain same. Row 3 will be changed only. अब आप इसको 104 से मल्टीप्लाई करें एंड इससे सब्ट्रैक्ट करें तो क्या आएगा, सॉरी माइनस 104 से मल्टीप्लाई करें और ऐड करें. यू गेट 0 हियर, यू गेट 0 हियर, एंड देन यहाँ पे ये जो एंट्री है ये क्या होगी, minus 36 plus 104 times 9 by 26. This will be this entry. इसको सॉल्व करें and tell me the entry. Now यहाँ पे क्या आएगा, ये वाली एंट्री क्या होगी, ये वाली एंट्री होगी minus 27 minus 104 divided by 26. Now tell me, solve this and tell me the entry. What is यहाँ पे क्या आएगा और यहाँ पे क्या आएगा? Tell me. Solve it quickly, please. Ji Farman Ali, can you tell me the value of these two entries?
Sir, I'm just doing it.
Sir, star 1 is 0.
स्टार में क्या आएगा?
0.
0 आएगा. अच्छा, और इसमें प्लस वाली में क्या आएगा?
minus 31.
प्लस वाली
Minus 31.
और ये स्टार वाली 0 आ रही है.
Yes, sir.
Yes, sir.
Okay, thank you. So this star entry is what? It is 0, and this plus entry is minus 31. This one. Now we stop here. Okay, for now. We get this system now. Okay. Let me write it again. 1 minus 11, 4, 3. 1 minus 11, 4, 3, 0, 1, and then minus 9 by 26, 1 by 26, 0, 0, 0, minus 31. Yeah, this one. So you have reached here. the corresponding linear system is. Now you have reached here. पहले हमने क्या किया था, हमारे पास लीनियर सिस्टम था, हमने ऑगमेंटेड मैट्रिक्स लिखा, ठीक है. अब हमारे पास ऑगमेंटेड मैट्रिक्स अगर ये है, तो कैन वी राइट बैक दैट लीनियर सिस्टम अगेन?
Yes, sir.
How can we write? The corresponding linear system will be what? x1 minus 11x2. xyz में लिखा था हमने, xyz में लिख लें उसको, ठीक है. So it will be x minus 11y plus 4z is equal to 3. And 0 यहाँ पे है, यहाँ पे y आ जाएगा, minus 9 by 26 z is equal to 126. And the third one is what? 0, 0, 0 is equal to minus 31. This is what we have obtained. Okay. What we have obtained here, this is the case we discussed in a 2 by 2 linear system. ये हमने केस जब डिस्कस किया था तो वो कौन सा केस था?
Sir, no solution.
No solution, because 0 is not equal to minus 31, ठीक है, which is a contradiction, which is a contradiction. Thus, the given system, the given linear system has no solution. Okay. क्यों? क्योंकि this is not possible. इस केस में क्या होगा, आपके पास या तो तीनों प्लेन्स पैरेलल हैं, उनका पॉइंट ऑफ इंटरसेक्शन या रीजन ऑफ इंटरसेक्शन कुछ भी नहीं है. दूसरी पॉसिबिलिटी क्या हो सकती है, दे आर इंटरसेक्टिंग बट दे हैव नो कॉमन रीजन ऑफ इंटरसेक्शन. So there is no solution. Okay. I hope you get it.
Do we have a way of figuring out कि कौन सा केस है कि मतलब parallel है intersecting without a common point?
We are not figuring that thing. We are not interested in that thing. We are interested only in finding the solution. Either it is unique solution or it is infinite many solutions. ठीक है? We don't care whether the planes are parallel or not. We need a solution, either unique solution or infinite many solutions. Okay? Now, let's get back to this form. अगर यहाँ पे कोई एक constant आ जाता, for example, if I change that linear system and get some constant here, maybe 1, ठीक है? अगर यहाँ पे 1 आ जाता तो फिर आपके पास यहाँ पे लास्ट इक्वेशन क्या बनती? z is equal to minus 31. ठीक है? In this case, what we do, ये corresponding linear system है उसके. So in this case, what we do basically, z की वैल्यू हमारे पास यहां से हम निकाल लेंगे z की वैल्यू. Put the value of z here, you get the value of y, and then by inserting value of z and y into equation 1, you can get the value of x. This is called backward substitution. ठीक है? बैकवर्ड सब्स्टिट्यूशन में क्या है, लास्ट इक्वेशन से आपके पास क्या आ जाएगी, z की वैल्यू आ जाएगी. ठीक है? आप इसको पुट कर दें, पुट इन रो 2 या इक्वेशन 2, पुट इन इक्वेशन 2. इक्वेशन 2 में पुट करें y minus 9 by 26 into minus 31 you and put it equal to 1 over 26. After solving it, you get the value of y. You find it and tell me what is the value of y. Now, after getting the value of y, you put the value of z and y into the equation 1 and solve it, you get the value of x. So this is called backward substitution method in order to solve that linear system. Thanks. For what? Moid Ali.
So new backward substitution.
How did we get 1z? How did we get 1z? It is assume that we get 1z here. Just to explain you how do we use backward substitution to solve the linear system, to solve for the values of x, y, and z.
Oh, I got it.
Okay. अगर आपके पास ये दोनों जीरो हो जाते हैं, you got it? If you have any question, you can ask me. For example, ये दोनों जीरो हो जाते हैं. It's again as an assumption. Okay, again it is assumption. So now the corresponding linear system which you write out of this augmented matrix, what it would be? It would be you would have two equations. ठीक है. अच्छा, आपके पास जब पहले Z1 हमने suppose किया था coefficient of Z1, in that case you will get unique solution. In the previous case, in that case you would get unique solution. It means all the three planes are intersecting at a single point. Okay. Now in this case, if the third row is completely zero and you get two equations, how many equations do you have? You have two equations. And how many unknowns you have? You have three unknowns. So at maximum, you can find two unknown variables from here. You can find the values of two unknown variables. The third one, you have to set it free variable. Okay. So we let z is equal to, you can set any variable as a free variable, but I'm going to set z is equal to t, where t belongs to r, as a free variable. Okay. If I set z as t, then again using backward substitution, now you put z is equal to t in equation 2. Put z is equal to t, put this in equation 2. You get the value of y, which is what? It is 1/26 minus plus 9/26 times t. Now, again, putting the value of z and y into equation 1, you get the value of x, which is what? It is 3 minus plus 11 times 1/26 plus 9/26t, and then minus 4t. You get this now. Now, your solution is what? Your solution is x is what? 3 plus, इसको solve करके मुझे दे दें आप, 11/26 plus 99/26t minus 4t. इसको solve करके तो मुझे simplify करके दें आप. Y is what? Y, the value of y is 1/26 plus 9/26t, and the value of z is what? T. So this is your solution now, where t belongs to r, and how many values t can have? It can have infinite many solutions, sorry, infinite many values. So these are basically infinite many solutions to the given linear system. In this case, all the three planes are either intersecting and making a straight line. Okay? Their point of intersections are infinite many. Intersection region between three planes is a straight line. Yes?
So can we say that whenever we assume a free variable, the lines don't have a unique solution, the planes don't have a unique solution?
Whenever there is only one free variable in the solution of a 3x3 system, if there is only one free variable, it means all the three planes are intersecting and making a straight line. Their common region of intersection is a straight line. There are infinite many points. अगर आपके पास जो केस 1 में हमने सबसे पहले डिस्कस किया था कि एक ही इक्वेशन है, उसमें 2 फ्री वेरिएबल्स आ रहे हो, इट मींस basically all the 3 planes are what? They are on the top of each other. There is infinite many solutions. ठीक है, अगर एक फ्री वेरिएबल है तो उनका कॉमन रीजन ऑफ इंटरसेक्शन स्ट्रेट लाइन है. अगर 2 फ्री वेरिएबल्स हैं, इसका मतलब क्या होगा? ऑल द 3 planes are on the top of each other. There are infinite many solutions. इन दोनों केसेस में infinite many solutions होंगे. लेकिन अगर 2 फ्री वेरिएबल्स हैं, इट मींस ऑल द 3 planes are on the top of each other. 2 free variables they basically make a plane, and 1 free variable make a straight line. So in this case, all the 3 planes are intersecting and making a straight line. ठीक है? I hope you get it. If you have any further question, you can ask me. I hope you get it, all this situation. ठीक है? You can have a look at these things. You can ask me question. I give you few seconds to look at these things, and then you can ask me any question. So if you have any question, you can ask me. Otherwise, let me explain you about some other things. Row echelon forms. रो एचेलॉन फॉर्म्स, अगर आपके पास कोई भी मैट्रिक्स है, जैसे कि हाँ अभी हमने एक मैट्रिक्स देखा, ठीक है, आप इसी को अगर ले लें तो क्या था? 2 4 -1 एंड 7, ठीक है, एंड 1 -11 4 3 10 -6 4 3, ठीक है. Echelon form has certain properties. So what are those properties? The first property is जो कि हमने step 1 में की थी. Try to make first non-zero entry in first row 1. ठीक है, पहली नॉन जीरो एंट्री को आप 1 बना दें मैट्रिक्स में, जो कि हमने क्या किया था? यहां पे हमने 1 बनाया था. ठीक है, बाकी को आप भूल लें. ये पहली प्रॉपर्टी है एचेलॉन फॉर्म की, रो एचेलॉन फॉर्म. जरूरी नहीं है कि आपका यहां पे 1 हो. ठीक है, अगर यहां पे सारी रोज में 0 है तो फिर आपने यहां पे 1 बनाना है. ठीक है, सो फर्स्ट नॉन जीरो एंट्री पहली रो में आपने इसको 1 बनाना है. दिस इज द फर्स्ट प्रॉपर्टी. ठीक है, सेकंड प्रॉपर्टी, जो भी फर्स्ट नॉन जीरो एंट्री है मैट्रिक्स में, आपने उसके नीचे सारी एंट्रीज को 0 बनाना है. ठीक है, उसके नीचे सारी एंट्रीज को 0 बनाना है. ठीक है, बाकी यहां पे जो मर्जी हो, वट एवर वी हैव हियर. ठीक है, एनी एंट्री, वी डोंट केयर अबाउट. ठीक है, ये दूसरी प्रॉपर्टी है कि आप पहली एंट्री को 1 बनाएं, फिर उसके नीचे सारी 0 बनाएं. कैसे 0 बनानी है? यूजिंग दोज एलिमेंट्री रो ऑपरेशंस. थर्ड प्रॉपर्टी क्या है? आप पहली एंट्री में 1 है, ठीक है, ऑल अदर एंट्रीज यू डोंट केयर अबाउट देम. ठीक है, आपने यहां पे भी 0 बना लिए. ठीक है, अब क्या करें? सेकंड रो में पहली नॉन जीरो एंट्री को 1 बनाएं, यहां पे 1 बना दें. ठीक है, दिस इज द थर्ड प्रॉपर्टी. फोर्थ प्रॉपर्टी, अगेन द सेम वन। आपने जो सेकंड रो में यहाँ पे 1 बनाया है, यहाँ पे जो मर्जी हो, ठीक है, कोई भी नॉन जीरो कांस्टेंट हो। आपने यहाँ पे जो 1 बनाया है उसके नीचे वाले सारे जीरो कर दें, जीरो बना दें, मेक देम जीरो, ठीक है। बाकी यहाँ पे जो मर्जी एंट्रीज हो, वी डोंट केयर अबाउट दैम। And similarly, continue this process until you get 1 in the last row. ठीक है? Continue this process. Let me erase that thing. नहीं, इसको erase ना करें, इसको erase कर लेते हैं। So what we do here, we try to we continue these things, and we try to make 1 here and then 1 here, 0 below, and then 1 here, 0 below, and then 1 here, 0 below. There's nothing, so we cannot make 0 below this 1. So we continue this process until there are no more rows. यहाँ पे कोई भी नॉन जीरो कॉन्स्टेंट्स हो सकते हैं, एनी नॉन जीरो कॉन्स्टेंट्स, और दिस वन। This is basically called an echelon form of a matrix, and we make this, we try to convert the given matrix, given augmented matrix, into this form, echelon form, and then we can use a backward substitution method to solve for each variable. So this is what is the echelon form, or you can say that the given matrix has been converted into echelon form using what? Using elementary row operations. And why we do so? Because after getting the original augmented matrix into echelon form, we write back that linear system, and we can use backward substitution method to solve that system. Okay? And this method is called Gauss elimination method. Okay? Or sometimes we call it Gaussian elimination method. Gaussian elimination method for solving linear systems. Okay? Now, this is the standard echelon form. जिसमें यहाँ पे 1 बन जाता है, यहाँ पे भी 1 बन जाता है. Now, what if we cannot make 1 here? आप यहाँ पे 1 बना लें, ठीक है? And then उसके नीचे सारे 0. फिर आप यहाँ पे 1 बना लें, उसके सारे नीचे 0, and so on. ठीक है? The first entry, the first property is what? The first non-zero entry in each row should be 1. इस रो में, पहली रो में फर्स्ट नॉन जीरो एंट्री 1 है, सेकंड रो में फर्स्ट नॉन जीरो एंट्री 1 है, थर्ड रो में फर्स्ट नॉन जीरो एंट्री 1 है, फोर्थ रो में फर्स्ट नॉन जीरो एंट्री 1 है. ठीक है? दिस इज द फर्स्ट प्रॉपर्टी. सेकंड प्रॉपर्टी क्या है कि इन ईच सक्सेसिव रो द नॉन जीरो एंट्री is on the right of the non-zero entry in the previous row. ठीक है, this is the second property. Means कि अगर इस रो में फर्स्ट नॉन जीरो एंट्री यहाँ पे है 1, तो नेक्स्ट रो में जो फर्स्ट नॉन जीरो एंट्री होगी वो इसके राइट पे होनी चाहिए, इसके राइट पे होनी चाहिए, इसके बिल्कुल नीचे हमेशा 0 होगा। ठीक है, दिस इज द सेकंड प्रॉपर्टी। बस ये दो ही प्रॉपर्टीज आपने याद रखनी है। ठीक है, तो अगर ये दो प्रॉपर्टीज सेटिस्फाई होती हैं तो कोई भी जो मैट्रिक्स है वो एचेलॉन फॉर्म में होगा। ठीक है, अब फॉर एग्जांपल अगर हम इसकी एक और एग्जांपल देखना चाहें तो यहां पे मैं एक और एग्जांपल लिख रहा हूं इसकी, यू ट्राई टू अंडरस्टैंड दैट थिंग। यहां पे पहली नॉन जीरो एंट्री यहां पे आपने 1 बना ली। ठीक है, सेकंड रो में ये दोनों फॉर एग्जांपल 0 आ गई। ठीक है, यहां पे बाकी सारी नॉन जीरो एंट्रीज हैं। ठीक है, यहां पे भी 0 आ जाता है। ठीक है, आपने इसके नीचे पहले सारे 0 कर लिए। ठीक है, यहां पे अब आपकी ये वाली एंट्री सारी 0 आ गई अगेन, तो आप 1 कहां पे बनाएं, फिर यहां पे बना लें, फिर इसके नीचे सारे 0 आने चाहिए। ठीक है, फिर आप थर्ड नॉन जीरो एंट्री जो होगी वो इसके राइट पे होनी चाहिए। यहां पे राइट पे 1 बनाए, इसके नीचे सारे 0, यहां पे कुछ भी होगा, 1 के ऊपर जो मर्जी हो, 1 के नीचे 0 बनाना है। फिर यहां पे भी कोई भी एलिमेंट्स हो सकते हैं, वी डोंट केयर अबाउट देम। फिर नेक्स्ट में फॉर एग्जांपल यहां पे आपने 0, यहां पे भी 0 आ गया, यहां पे भी 0 आ गया, यू कैन नॉट मेक 1 हियर, तो यू कैन मेक 1 हियर। ठीक है, यहां पे फिर कुछ भी आ गया, इसके नीचे सारे 0। ठीक है, फिर आपने इस रो में आखिर में फर्स्ट नॉन जीरो एंट्री 1 बनानी है। फॉर एग्जांपल ये वाली सारी की सारी रो 0 आ जाती है, तो इट डजंट मैटर। नाउ दिस मैट्रिक्स इज इन एचेलॉन फॉर्म। ओके, क्योंकि दोनों प्रॉपर्टीज एचेलॉन फॉर्म की ये सेटिस्फाई करता है। क्या? इन ईच रो फर्स्ट नॉन जीरो एंट्री इज 1, इन ईच रो फर्स्ट नॉन जीरो एंट्री इज 1। ठीक है, दूसरी प्रॉपर्टी क्या है? इन ईच सक्सेसिव रो द फर्स्ट नॉन जीरो एंट्री इज ऑन द राइट ऑफ द नॉन जीरो एंट्री इन द प्रीवियस रो। सो फर्स्ट नॉन जीरो एंट्री ये है, नेक्स्ट रो में जो नॉन जीरो एंट्री है वो इसके राइट पे है, ये भी इसके राइट पे है, ये भी इसके राइट पे है, ये भी इसके राइट पे है। ठीक है, सो दिस इज द सेकंड प्रॉपर्टी, यहां से ये राइट पे जाना चाहिए नॉन जीरो एंट्रीज को। So this is basically echelon form, and these positions basically, ये वाली जो positions हैं इनको pivot positions कहते हैं।
सर सॉरी, आप दूसरी जो प्रॉपर्टी थी जो वो आप कहते हैं हर रो में राइट की तरफ हो, वो जरा फिर से फ्रेज कर सकते हैं किस तरह?
In each successive row, the first non-zero entry should be on the right of the non-zero entry in the previous row.
ओके, सही समझ आ गया।
समझ आ गया? ठीक है, in each successive row the first non-zero entry should be on the right of the first non-zero entry in the above row या previous row। तो ये दोनों प्रॉपर्टी सेटिस्फाई हो रही हैं, बाकी इनके नीचे 0 होना चाहिए। ठीक है, ये थर्ड प्रॉपर्टी है एचेलॉन फॉर्म की। 3 ही प्रॉपर्टीज हैं। पहली प्रॉपर्टी, each first non-zero in each row, first non-zero entry in each row should be 1. Second property क्या है? In each successive row, the first non-zero entry should be on the right of the non-zero entry in the previous row. Third property क्या है? कि जितनी आपकी ones हैं, इनके नीचे 0 होना चाहिए। अगर, और ये हमने बनाना होता है किसी भी लीनियर सिस्टम में, उसको एचेलॉन फॉर्म में कन्वर्ट करना होता है। Why? In order to solve that given linear system. And what we are doing actually in the back end, we are solving the given linear system simultaneously. Okay? And after converting the given matrix into echelon form, what we do, we write back the corresponding linear system and we use backward substitution to solve for all the variables x, y, z, any number of variables. Okay. I hope you get it. If you have any question, you can ask me. Today we stop here for now. If you have any question, you can ask me regarding today's lecture.
Sir, एग्जाम में हमारे पास मतलब मैक्सिमम 3x3 सिस्टम आएगा ना?
कोई जरूरी नहीं है, 4x4 भी आ सकता है, 5x5 भी आ सकता है.
ओके सर.
ठीक है.
Sir, जो echelon